Hello, welcome again. Solving trig equations. That's example 2. I previous video had one example of solving trig equations. These are the quadratic type one more time. So we want to be able to recognize um, that there's a square associated, which might change things a little bit here and there. Also, this is the one that does not use identities yet. Please notice we do have restrictions on the domain. And I do see this equation. Again, if you're still not comfortable being able to solve with trig in the equation itself, feel free to replace it with x, not the square. Just the cosine of theta is x, which makes this 4x squared minus 3 equals 0. Add 3 to both sides, divide by 4, and then square root both sides, right? That's with using algebra. If you're able to handle it, like I said, just by itself, it's the same steps. Add 3 to both sides, divide by 4, and then square root both sides so that we have just cosine theta here. And then when I square root 3 over 4, please know that there's going to be a positive and a negative associated with it, just like we've done in class. Square root of 25 is just not 5. It also is negative 5. So all square roots, they come in couples. The answers come in pairs. Couples can be used. That's a cool word. So now, oh, you know what? Actually, if you notice, if you look at this, I could split this up because this number looks weird. You could split up the square roots, and guess what? The denominator is nothing but 2, and this would be also 2. There we go. So we split up our question. We basically have two subsets of the question here. We're looking for a theta value where cosine ratio is root 3 over 2. And at the same time, we're looking for another theta value where cosine ratio is root 3 over 2. So let's start solving this. For what theta does that equal? These two ratios. Now, if we have the first quadrant kind of memorized, we should be able to get to the answer right away. For example, 30 degrees, 45, and 60. The sine value here is half, and that's the one I have memorized. From here, all I do is going to 60, you can go ahead and flip these values. And then the 45 is doing its own thing. Both sine and cosine are root 2 over 2. So if you just look at this, we're looking for cosine value of root 3 over 2, which sits right here, which means that's the angle. Theta must equal pi over 6. Also, no, cosine is positive in both first and fourth quadrant. So there's going to be another angle, which is going to be nothing but a reflection of the first angle that we picked. And because that's a reflection, the x value will still be the same. Y value is going to switch to negative. And in this case, we really don't care about the y value. So what angle would this be is the question. Since we're going up in sixths, and then the entire circle would have 12 parts, because pi is split into 6 parts. 1, 2, 3, 4. Oh, no, it's not split into 6 parts. It's actually pi over 6, pi over 4, pi over 3. So my only concern is what angle is this? Since we are going up, since this is a sixth, this one would also be a sixth, except it's in the negative direction. But that's a reference angle. So the entire angle, this whole angle, going counterclockwise would be 11 pi over 6. Right? Because the entire circle will be 12 sections. One section less would be 11 pi over 6. So that gets me both the answers from here. Also, no, there's no point in going over and over again just because our domain is restricted to one rotation. So there will be only two possible theta values when cosine is positive. And when cosine is negative, so when we're looking at this, cosine is negative in the second and third quadrant. So there should be, again, two reference angles, one this and one would be that. I mean, again, if you have kind of this memorized, like I said, we wouldn't have to make any triangles. So negative would be simply a reflection of this on the other side. This would be the angle. This is where cosine will be negative, but sine will stay positive. Since we're going up in 6 just for this angle, this one will refer to 5 pi over 6. And the other one would be in the third quadrant. If this is 5 over 6, this would be 6 pi over 6, and this would be 7 pi over 6. And that's what this angle would represent. The two theta values from those will be 5 pi over 6 and 7 pi over 6. Now that was without making triangles. If you can't connect to this, which is basically a little bit of memorization of the first quadrant, then everything else is a reflection of it. If you still can't do that, then go the traditional route. This is the adjacent, that's the hypotenuse. So adjacent, negative root 3, hypotenuse is 2, and hence this will be 1, which helps you determine that this angle would be 30 degrees, which means the reference angle would be 150 degrees, and the equivalent of that in radians would be 5 pi over 6. And that's how we get this first answer. I've shown you both ways, basically, if you're following along the video. And then comes in, so if this is 30 degrees and this is also 30 degrees, that's a reference angle though. And then the entire angle would be 180 plus another 30, which would be 210 degrees. And the radian equivalent of that is 7 pi over 6. Okay, and so those are the 4 answers. How do I know there are only 4 answers? Because anytime I start adding 2 pi to this, well, I'm going to write one more time, the sine and cosine, they are periodic every 2 pi. So their answers repeat every 2 pi. But in this case, I'm not going to add the 2 pi's just because I'm going to go outside of the range. So we have a total of 4 answers. Let's put it together. Theta equals, start with the lowest, there we go. That is our final answer. Those 4 theta values satisfies our original equation. All right, that was the second example. In the same video, I'm going to give you another example, also quadratics, also without identities. This is very similar to the previous question, but I thought I'll throw in a tangent one as well. If you want to call x as your tangent theta, then this would be x squared equals 1/3. And x would be square root of 1/3, and then negative square root of 1/3. Obviously, we're not going to put the negative inside the square root sign because that'll make it imaginary numbers. No, this is going to be on the outside. I'm going to break it up real quick. Square root of 1 and square root of 3. Negative square root of 1, square root of 3. That makes this 1 over root 3 or negative 1 over root 3. Time to bring back the tangent. Tangent theta must equal 1 over root 3 or tangent theta must equal negative 1 over root 3. I'm going to split my section here because we are looking for tangent values which will satisfy both the ratios. Now with the tangent is positive in the first and the third quadrant. Because tangent is a ratio of y and x. Tangent is basically the ratio of y over x. In first quadrant, both are positive. In third quadrant, both x and y are negative. So since they're both negative, tangent becomes positive here. Tangent is going to be negative in the second quadrant because in the second quadrant, x is negative. And in the fourth quadrant, y is the one that's negative and x is positive. And since tangent is a ratio of these, tangent will be negative in these two quadrants. Anyway, so for this question, we are looking at first and third quadrant. There must be a theta here. Let's go ahead and finish that. Opposite over adjacent, hence this must be 2. And then there must be another theta here in the third quadrant. Complete the triangle. Triangle is always completed with the x-axis. Opposite, so that would be root 3 over adjacent, which is 1. But if you notice, this is still positive, but I'm in third quadrant. I'm supposed to put this with both of them because the ratio will still turn out to be positive. and hence this would be positive. Now the only thing is this theta would equal, since this angle is opposite to 1, this theta would equal pi over 6. So 1 of my theta is pi over 6. And over here, this is also pi over 6, but that's the reference angle. Our total angle is all the way here, which is pi plus pi over 6, which will make it 7 pi over 6. Okay, I got both the tangent values from there, and this question also had the restriction, so we're not going to add 2 pi's because we'll get outside of the range. Now for negative value of tangent, that only happens in second and fourth quadrant. The second quadrant, here's our theta, complete the triangle, opposite over adjacent. So I have to automatically adjust. Just because the negative is sitting up there with 1 doesn't mean I have to have that negative stick with the 1. Considering we are in the second quadrant, it's the adjacent side that has to be negative, so we put it there. Doesn't matter, the ratio is still negative. Hence, this must be 2. No, we don't want to match colors. And then the other will be here, this theta. Also, both these thetas are reference angles. Anyway, opposite over adjacent, so that works, and this must be 2. Right? And I adjusted the negative accordingly because this side must be negative. This side is not going to be negative. Okay, now I just have to determine the angles. This must be a 30-degree angle just because opposite to side 1. And that means pi over 6, which means the actual angle would be 5 pi over 6, the leftover. And then from here, this would also be pi over 6, just going in the opposite direction. So the entire angle from here to here would be 1 less than 12 pi over 6. So we'll make it 11 pi over 6. And these are my 4 answers. Again, we're not going to add 2 pi just because we have domain restrictions. So total answers. Time to put down our answer. This is our set of answers. We have a total of 4 of them. Here's the question in its totality. There we go. One more time just on the, well, actually we're done. All right, let's see. Yeah, I'm going to make another example in a different video and see you then. All right, bye.